So what do trees do when the climate changes? Well, they migrate. And we know that from the history, what we call the paleoecological history. This is spruce, for example. This was the northern edge of the range of spruce 15,000 years ago. 11,000 years ago on that line there, it was just reaching Duluth. Right? At that time, the glaciers were receding, the climate was warming, and spruce had been hanging out down here in Missouri and Tennessee, and it started to move north when it warmed. So that's what trees basically do, and the same for white pine. It hung out in Virginia there and then moved up to New England, then it took a left turn and came out to Minnesota. Only got to Itasca State Park 2,000 years ago, even though it had been in Duluth for 7,000 years. And that's because the climate was getting cooler and trees were moving out onto the prairie. And probably actually where it was hanging out was out here in the ocean. Because you have to remember, at the peak of the last glaciation, the ocean was 350 feet lower than it is now, because all that water was in the ice sheets. So, and Florida was a very large state then. It was, especially their shallow water on the west side of Florida, it was about 300 miles in width. It's been getting smaller ever since then. And people think just because they built some condos on the beach, it's going to stop doing that. But it isn't going to stop doing that. It's been getting smaller for the last 20,000 years, and it's going to keep right on getting smaller, regardless of anything that people do. Here's projections of future range for a tree which is important in Minnesota, the black spruce. Go from here down to here and back up every 100,000 years. Every time there's a glacial cycle, black spruce goes down to Tennessee and then goes back up to Hudson's Bay and so on. So we're right on the prairie forest border here in Minnesota. That's the black line. We're right there. As Garrison Keillor says, a little town on the edge of the prairie. Well, in the future, he might have to say the little town in the middle of the prairie. Because with the climate change that we're projecting for the high emission scenario, this prairie forest border would go to Thunder Bay. So, and this has happened before. I mean, it's not new to the world. It's not new to the trees or to the prairie. It is new to people, though. This has happened in the past, and it's in the paleoecological record. For example, 7,000 years ago, there's oak and grass pollen in the bogs in the Ely area. And that's when we were at the peak of the interglacial we're in now, and summers were much warmer than they are now. However, the future warming we think will be bigger in magnitude compared to where we were 7,000 years ago. So you've all heard that scientists expect a lot of species to go extinct in a warmer climate. And why is that? We had changes in climate in the past, and all the species we have now are here. Well, the rate of change is going to be faster. There's a fragmented environment that species have to migrate through. They have to compete with invasive species. There's a lot of exotic diseases killing off our native trees and plants. And then we have deer grazing as an issue. We have a much higher deer population now than we did. So these things will make climate change much more difficult for our native forests to deal with than if they just were responding to climate change only and people had not changed any other aspects of the environment. Storms, for example. This is the big blowdown in the boundary waters, a before and after picture. Big thunderstorm with straight line winds. The damage path goes all the way to Maine. In fact, it was the most severe thunderstorm ever recorded by meteorologists. It had 6,000 cloud-to-ground lightning strikes per hour from Minnesota all the way to Maine. As the storm passed over, it had winds of 120 miles an hour for about 20 minutes and up to 7 inches of rain in about a half hour or slightly more than a half hour. It actually floated a bog from one watershed into another watershed in northern Minnesota. Lifted the peat moss and up over the watershed boundary into another watershed, and the acidity killed the fish in that other river all the way to Lake Superior. Because the other watershed didn't have any peat in it, and it wasn't acidic. But this is the type of wind damage. I mean, someday one of these is going to hit Minneapolis and it'll be about $10 billion. You know, if this same storm hit Minneapolis, it would clear out all of the skyscrapers in both cities and all the office buildings in the whole town, and all the trees would be down. I mean, there wouldn't be a tree standing anywhere in the Twin Cities. The power grid would be totally knocked out, and it would take months to rebuild it. So someday it'll happen. It's just a matter of rolling the dice. But those dice might come up positive more often in the future because a warmer climate will favor these big storms. We don't think there will be more storms, but the storms that do occur will be more severe. There's already been enough warming since the year 1900 to cause major changes to forests. So I told you it was going to get drier in the summer, right? Higher temperatures and less rain. Inevitably, that's going to thin out the density of trees. There'll be fewer trees. Each tree will get the same amount of water, but there's less total water. They'll just have bigger root systems and thinner trees. And there are bugs that play a big role in climate change. They explode in a changing climate, and they kill the forest. This is mountain pine, and earthworms facilitate invasive plants, including buckthorn and garlic mustard shown here. And this is just very recent evidence that, in fact, these plants don't become invasive and spread over large areas until earthworms are there first. They are co-evolved with each other on their home continent. And buckthorn and garlic mustard, and also the Tatarian honeysuckle, probably leaving a few out, but all invasive plants basically are tied to earthworms. And so and then our native plants at a time of changing climate have to compete with these invasive species that don't care about the climate, okay? So they can get along in a wide range of climates next. What a warmer climate really does is the things in these blue ovals. It makes more droughts that warm up the soil and kill trees. The worms can spread faster. They kill seedlings mostly. It lets deer populations be higher in a place like northern Minnesota, and they eat seedlings. More forest fires, certainly in a warmer climate, more droughts, more windstorms blowing trees down, and more pests and diseases. Now the CO2 fertilization effect, because CO2 after all is a plant nutrient that they need. Cellulose is nothing but a bunch of CO2 molecules strung together in a chain. That's what the plant builds itself out of, is cellulose. So they need CO2, and the more CO2 there is in the atmosphere, the shorter the time they need to open their stomata, which are pores on the leaves to take CO2 in, which means less water evaporates, so they become slightly more drought tolerant. But we think that CO2 fertilization effect will actually only negate maybe 20% of the increasing drought stress in the future. So there will still be a lot more drought stress even with the CO2 fertilization effect. And not only that, in 3 or 4 decades we'll reach the saturation point of CO2 for plants anyway. It's to 560 parts per million, and you can go higher than that and it makes no difference, because the CO2 molecules are competing with each other to get into those little pores. And it's kind of like the width of an intersection in a downtown street at rush hour. You know, only so many cars can fit through there. So here's a climate envelope for the Arrowhead, where the Boundary Waters is. By the middle of this century, climate of the Boundary Waters would be equal to that area, Twin Cities down through north central Iowa. And you have to ask yourself, can moose really live in that climate? Well, no, otherwise there'd be moose here. Can lynx live in that climate? Well, no. What can live in that climate? This is the corn belt. The brown areas are high productivity of corn. So the Boundary Waters will have the climate of the corn belt, except that you can't grow corn on granite. So that's an issue for farmers, because right now the ideal climate and soils are together as a pair, and in the future they won't be.